Hello, everyone. My name is Felipe Sabadin. I'm the small grains BD at Utah State University, and today I'm going to show you the project that we are submitting to Idaho Wheat Commission. So I'll be serving as a PI, and Dr. John Lee Shane from University of Idaho is going to be the co-PI. And the project name is Unraveling the Genetic Architecture of Early Root System in Winter Wheat Under Drought Conditions. So everybody knows that drought is a principal factor that limits crop yield. And only here in the United States, we have more than $90 billion per year in losses. And also, drought not only reduces yields, but also the quality of the final product. So it's a very common situation here for Utah, but also for Idaho, especially in the southern part of Idaho, where the most part of the wheat production is under dry land. And it's something that the farmers are used to deal all the time. So the plant has just two different strategies to deal with drought. One is reducing water loss, another one is increasing water absorption by roots. So, but root is a very complex system, and there's a lot of different traits. And we have root length, root angle, root biomass, and all these traits together we are used to call as a root system architecture. So, because it's a very hard phenotype to take, so the breeding programs doesn't have the capacity to do this because we are evaluating thousands of different genotypes in the field. So because of that, there's a lacking information on root traits in the breeding context. Also, we don't know exactly how these early root traits are connected with end-user traits, for example, like grain yield. And this is why I want to do this project and develop this project. I want to understand a little bit more the genetic diversity that we have for root traits and how we could explore this genetic diversity to develop better and more resilient wheat varieties. So for that, we are going to use genomic information, high throughput phenotyping, all these new tools together to try to understand better this new system. So we already have a winter wheat panel developed by Dr. John Lee Shane. So it's composed by 180 winter wheat lines adapted to the Intermountain West region. And it's composed by released varieties, but also breeding lines. And all this panel is already genotyped. So we can take advantage for this set and study root system as well. So for that, we are gonna do two different experiments, one in laboratory, another one in greenhouse. And we're gonna apply two different treatments for all those lines. So well weather, but also a drought condition. So in a laboratory, we're gonna evaluate the root seedlings, and then you guys can see in the left part of this slide. But in the greenhouse, we're gonna carry out these plants a little longer, and then we're gonna have a good idea about the root system in the early growth stages. So we're gonna use traditional methods, but also images and connecting the genotype information that we already have to understand the genetic diversity, the genetic architecture, and also if we can predict some phenotypes only using genetic information. So we expect to understand better the genetic architecture for root traits under drought conditions. And we also want to develop some genomic tools and high throughput phenotype tools that could be used not only by the Utah State University and the University of Idaho, but other wheat breeding programs as well. So, and also we will identify some genetic sources or some better lines that we could use as a parent in our program just to try to make or to develop the better crosses, better populations, and increase the probability to release a better variety or more resilient varieties to drought conditions. So, and finally, I want to create a background for a future NIFA project where I will evaluate all these lines in the field and try to connect all these phenotypes in the greenhouse, in laboratory, but also with phenotype that we can collect in the field. So thank you for the opportunity to show the project for you guys.